Hello, I'm going to explain uh, behavior of acids with metals. If you study five metals: copper, magnesium, aluminum, zinc, and iron. So, comparatively, magnesium is more reactive than aluminum, and aluminum is more reactive than zinc, and zinc is more reactive than iron. And the copper. So, these four metals they liberate hydrogen from acids. But in case of copper, copper does not react with acids, so it does not liberate hydrogen from acids. So I explain, and the acids that you have to study are sulfuric acid, hydrochloric acid, and nitric acid. So the behavior of nitric acid is quite different here, and so particularly the sulfuric acid and hydrochloric acid they react with metals to liberate hydrogen. Hello, I'm just going to explain about the general characteristic properties of acids. Okay, I'm leaving the physical properties. Acids are sour in taste. They do have litmus test. It changes the blue litmus to red like this. And methyl orange, okay, turns red when in acidic medium, etc. But I will start with the reaction with metals. So acids react with active metals like zinc, magnesium, etc. and with the evolution of hydrogen gas. Okay, so the reaction is like this: zinc plus zinc in the solid form plus sulfuric acid in aqueous form. Aqueous means water mix. It is dilute form. This you can say dilute. In the dilute form, it's okay. You will get zinc will react with sulfuric acid. Zinc is a metal, so it is a positive radical, and this is a negative radical. So zinc will react with sulfate to form zinc sulfate. Zinc sulfate. This is aqueous, and hydrogen gas you will get. This is hydrogen gas. That's right. Now, in this case, you know how the reaction takes place. Zinc is a metal. Okay, it forms positive radical by losing electrons. Now, sulfate is a negative radical. So, zinc will react with sulfate to form zinc sulfate in the aqueous form. So, okay, and this hydrogen gas will be evolved. This is zinc sulfate. Zinc sulfate. This is zinc sulfate. So, okay, in the same way, zinc is an active metal, so zinc will react with HCl. Zinc it is in a solid form. This you have to denote. Zinc in the solid form, HCl in the aqueous form. So that will react in this way. Zinc will react with chlorine. This chloride, so form zinc chloride. Okay, this is in aqueous form plus hydrogen gas is evolved. So okay, hydrogen gas is evolved. It is. So the valency of zinc is 2. Therefore, that goes to chlorine. So it forms zinc chloride, and this is hydrogen. In order to balance this, look here, chlorine is not balanced. The chlorine in the right side is 2 here now. So put 2 here now. So in this case, hydrogen and chlorine, so both are okay, balanced now. So the general property of metal, general of this acid with metal is that metal plus acid, it reacts to give metal salt. Metal salt plus hydrogen gas. Hydrogen gas. Okay. Now, one important thing about acid, is that all the acids do not react with metals to form hydrogen gas, right? For example, the behavior of nitric acid is quite different. Behavior of nitric acid is quite different. Nitric acid, okay, it does not evolve hydrogen. It's because nitric acid is a very strong oxidizing agent, isn't it here? So whenever the hydrogen is evolved from the reaction, it immediately oxidizes to water, and it still gets reduced to any of the nitrogen oxide, like N2O or this NO or NO2 it is. So, okay, did you follow? So I told that the behavior of nitric acid with metal is different. Okay, so it does not evolve hydrogen from acids. It is because nitric acid is a very strong oxidizing agent. Immediately after the evolution of hydrogen gas, it oxidizes hydrogen into water, and itself gets reduced, okay, to any of the nitrogen oxide here, like N2O, NO, or NO2 it is. But okay, magnesium, but magnesium and manganese and manganese. Okay, the magnesium has the symbol Mg, and this is as Mn. Okay, they react with, okay, these two react with very dilute acid, okay, of this nitric acid. Very dilute nitric acid evolve hydrogen gas. So, okay, the reaction is like this. So magnesium plus HNO3. This you can see solid form. This is solid form, and this is aqueous. This is very dilute here now. Yeah. So we'll get magnesium nitrate. Okay, and this hydrogen gas is evolved. Okay, hydrogen gas is evolved, right? This is the reaction. In the same way, manganese also react with dilute nitric acid, very dilute nitric acid, to evolve hydrogen gas. This is in the gaseous form. Clear? Yeah. Now, the reactive, we have to study okay, 4 or 5 metals here, like magnesium, aluminum, zinc, and iron. Okay, the reactivity of these metals, okay, are different. Okay, magnesium, the reactivity series, if I write here now, like a reactivity series of reactivity series we can write now, like here. So magnesium Mg is stronger than aluminum, is stronger than zinc, is stronger than iron, isn't it? Here, like this. So out of these 4, magnesium is the strongest one. It's okay. So this react, okay, magnesium reacts very readily with acids. Aluminum reacts less readily, means very not so easily here. Zinc react less react, and iron the least with acid. Out of these 4 metals I am talking about, right? So the behavior of nitric acid is quite different with metals. Reaction of copper with acid. So copper does not react with acids. Copper does not react with acids. Okay. Copper does not react with acids. Copper metal, okay, does not react with acids. So it does not evolve hydrogen gas from acids.